Hello, our amazing listeners of Neurocareers doing the impossible. It's your podcast host, Dr. Milena Krastenskaya, or simply Dr. K. And I'm excited to welcome you to the second season of our podcast, exploring entrepreneurial careers in neuroscience and neurotechnologies. Have you ever wondered what it takes to transform brain science into groundbreaking products and services? Are you curious about the fearless visionaries who bridge the gap between neuroscience and entrepreneurship to change people's life and reshape our world? Are you ready to explore how to navigate the uncharted waters of neurotech entrepreneurship? In season 2, we're diving deep into the world of entrepreneurial ventures in neuroscience and neurotechnologies. If you are looking to create an immediate impact and translate your neuroscience and neurotech ideas into innovative services that truly make a difference in the world, this season is tailor made for you. Join us and learn from the best in the field about succeeding in the entrepreneurial journey in neuroscience and neurotechnology where innovation meets impact. We've got an incredible lineup of guests who are not only shaped their careers, but have also made a profound impact on the field. Throughout this season, we'll explore the captivating stories of visionaries who've risen to the challenge, who've turned obstacles into opportunities, and who've innovated in ways that are changing the landscape of neurocareers. So, whether you are a seasoned professional in the field, an inspiring entrepreneur, or simply curious about the intersection of science and business in this ever evolving arena, the season promises inspiration, education, and a glimpse into the exciting future of neurocareers. I am Dr. Milena Krastenskaya, the founder of the Institute of Neuroapproaches, where I help people establish successful careers in neuroscience and neurotechnologies through career coaching and education. So let's dive into the entrepreneurial journeys that are shaping the future of neuroscience and neurotechnologies together. Tune in now into the thrilling episode number 73. Welcome, dear listeners, to another enlightening episode of Neurocareers Doing the Impossible podcast. Today, we have a privilege of introducing you to an extraordinary guest who is pioneering the world of neurotechnology and open source innovation. Meet Ildar Rakhmatulin, a hardware and software engineer with a profound interest in neural interfaces and real-time data processing. Ildar's journey has led him to create PiEEG, a groundbreaking open source Raspberry Pi shield designed to measure essential biosignals, including electroencephalography, electromyography, and electrocardiography. This versatile and user-friendly platform opens up new possibilities for measuring biosignals and has applications across various fields, from gaming to entertainment to sports, health, and meditation. One of the most exciting aspects of PiEEG is its accessibility. Ildar's design allows anyone to connect electrodes and run a Python script to start measuring biosignals, democratizing access to vital data. This innovation holds the potential to transform how we understand and interact with our own physiology. In this episode, we'll explore Ildar's journey into the world of wearable technology and neurointerfaces. We will delve into the significance of PiEEG and its implications for neuroscience, health, and beyond. Additionally, we will discuss Ildar's passion for open source collaboration, including his contributions to projects such as PiEEG and Iron BCI. Join us as we uncover the boundless potential of PiEEG and its impact on the world of neurotechnology with Ildar Rakhmatulin, a true trailblazer in the realm of open source hardware and data driven innovation. Welcome, Ildar. It's a great pleasure to have you today on our podcast. Thank you very much for coming. And can you please tell our listeners where you are joining us from? From what part of the world?
Hello, Milena. It's a very nice introduction, really. And I'm happy to be here today. Originally, I'm from Russia, and after that, I lived about 5 years in Japan. And in the current moment, I'm in United Kingdom, in Scotland, Edinburgh. So it was a long way.
How is the weather today in Edinburgh?
It's also raining, and raining. I'm really already missed for sun.
What's your favorite place in Edinburgh? Where would you recommend our listeners visiting when they come to visit Edinburgh?
Great question. Maybe it's August during some festival. It's many festival during August in Edinburgh. It's great time because without any problem you can find some interesting places to see some activities, some event, different types of events, spectacles. And it's really amazing time, and especially August.
Okay, August. Okay. Yes. So, wonderful. We already know something interesting about the place where you live and do your work currently. Now, let's talk about your background. I know you're an engineer. You have an engineering background. How did you come to become an engineer? What prompted you to become an engineer?
Happened many years ago, and I cannot say that it was my choice because when I finished just only school, I was too young, and my parents were engineers, so and just only for this reason, yeah, I chose this direction. And for me, but actually, of course, engineering is a big field, big area, and after that, already I found exactly an area that's interesting for me, especially hardware, software, and machine learning and signal processing, and especially in hardware and healthcare area.
hmm So, how did you find this specialization? Why machine learning, software, hardware, and how were you acquiring those skills? What did you do during your bachelor's and then your PhD? What areas you were developing? Can you give us more detail?
About my PhD, actually, it was not correlated with healthcare, with neuroscience. I just only developed some hardware devices to track position of the sun and for solar panel. But for me, it always was much more interesting, something much more applied that can be easily applied in real life, that can have impact for people, and that can be using for everyone. So, and already during my PhD, I already pay attention for some wearable devices. And I can say that already from this time, I started much more deeply study this area.
Mm-hmm.
And step by step, yeah, it was one way. Yeah.
Yeah. So, can you tell a little bit more of how did you get into neuroscience, neurotechnologies? Where did you first time learn about it? And then how were you acquiring those skills in neurotech that you are using right now?
I believe that it will be not surprised if you ask many people about neuroscience. I believe that many people will say something like about control robotic system, control robotic arm, and exactly it happened and with me. I have big experience in hardware and electronics during many years. I worked in this area. I developed different types of laboratory equipment. And very deeply, I started work already with machine learning. And I didn't know actually where I can apply my skills with machine learning. I want to find something really cool, really interesting. And I always, of course, what interesting for me was neuroscience. And I decided, okay, maybe it's great time already. Start test my knowledge, started my experience in this area. Yeah, it's exactly first step. How I meet with neuroscience because I had experience with hardware, machine learning, but for me, it was necessarily find some applied area, something inspire area, not just only something simple, but some area where I can work a very long time. Because for me it was always was problem. Uh, I always was afraid that in some days in the morning I will wake up and I will don't know what I will do today. For example, if I will achieve some result, some result in, for example, in hardware, you already know how it works, and sometimes you don't know what you can do now. But actually, in neuroscience, I believe it. In my age, of course, it never happened that I wake up and I will not know what I will do today because it's very big area. And every day I know what I can improve. It's not just only software; it's machine learning, it's software, it's signal processing. It's very inspiring, and every day is busy in this area. And for this reason, and I chose this direction. And of course, because it's healthcare area, in this area, if you will, anyway, if you will not receive any positive result, for example, from the point of view of money or something like that, but anyway, it will be a contribution to the healthcare science. Anyway, you work in the area where you try to help people.
Absolutely. Can you guide a little bit through your journey acquiring different experiences and skills that brought you to already creating a PiEEG? You mentioned that you've been in quite a few places before you came now to the UK, to Edinburgh. So, can you guide you through your journey in terms of acquiring those skills that you are using now?
Yeah, how I mentioned, I always work at the most part of my life in hardware area.
Mhm.
But
Yeah.
actually, when I want to start with neuroscience, initially I didn't want to work with hardware because from my side, I believe that I already had necessary experience in hardware. It was not so much interesting for me. I just wanted to implement some of my algorithms for signal processing, for machine learning, but I was very surprised many years ago since I didn't find any in the first low cost and in the second enough for me open source any brain computer interfaces. It was very expensive. It was not so easy buy it. In the first maybe few weeks, I believe that maybe I'm do something wrong because I'm already a customer, like a hardware engineer. That if you would like some hardware are through already in our days, you can find without any problem some equipment in the market. And I could not believe why I cannot find brain computer interface. Maybe I do something wrong, and I spent really a few weeks about that, just only try to find something. And finally, I understand. Looks like it is a very big gap in this area because it's really something that exists in the market it was very expensive. It was not enough open source for me. So for this reason, I decided that I have only one choice. I should create a short brain computer interface myself. And I started create my first device. It was Iron BCI.
Mm-hmm. Yes. Can you tell us more about Iron BCI?
Of course, I believe it that actually that it will not take so much time because I'm hardware engineer. In the first, when I just only first time look at okay, EG, just only measure microvolt. Okay, I can do it very quickly. And I expected that maybe it takes 1 month, maybe two, but finally it takes about 1 year. It was many problems actually because it's very precisable device, macro, so it was necessary created very low with very good power supply, very good analog digital converter. Also, I made some experience with active electrodes and microcontrollers, data transmissions, and any electromagnetic noise. And in the first stage, when I finished my first prototype, I just could not understand if it works or not. I didn't have enough background to understand if it is EEG or not. But actually, since I started making this device in open source, it has significantly helped me because it has allowed me establish networking and neuroscience world. I was surprised, but many very, very big scientists from this area started helping me in this area, actually in signal processing and and data analyze. And yes, about few months, I just worked with data. I try, and also I try implemented many different types of framework in my devices to work with signal processing. Yeah, and finally, yes, because it's when you work with brain computer interface or any EG devices, it is not just only microvolts. Actually, it's mechanical problem because it should be very good connection between electrode and head. It is also chemical moment because you should clearly understand about which type of electrodes you connect, which cables you use, how this cable is connected. You should save these cables from any electromagnetic noise. It also electronics. Electronics should be with very good accuracy, precisable, with very good quality, and also with data with also with wireless technology, because wireless technology can be very powerful. It also can damage any signal with noise from Wi-Fi, from Bluetooth, and of course it is signal processing. So for this reason, finally, it take for me for create first prototype about 1 year. And many people actually participated, many people helped me. But finally, first device was ready, Aaron BCI, and I made this device in open source format. And it became really very popular, and many people after that created this device and connected me that they would like to use it. And after that, I can explain it why I started my PiEEG and why I didn't stop work with Iron BCI. But maybe you will ask me about that.
Yes, and I will ask a couple of more questions. Before that, you mentioned that there were quite a few problems and you elaborated on some of them. If you would pinpoint just one biggest challenge that you faced when creating this first Iron BCI, what was it?
It exactly receives in real time clear EEG signals, especially algorithm. Of course, I started with, for me, big challenge was just only to see in real time blinking, achieving artifacts. But this moment when I confirmed that my device really clearly works, when I see how it works with algorithm. Close it, open eyes, and you really can see almost in real time that it is work. Because yeah, it takes much time for me, especially especially signal processing because it should be because initial task was not just create brain computer interface. My initial task was create brain computer interface for everyday life, not just only for laboratory reason. For this reason, I pay very much attention for accuracy, that it should be very safety from any types of noise. Also, I already understood that EEG signal is not stationary signal. It's a very complicated signal. Actually, it cannot, for example, it can work for some tasks with my body today, but it not doesn't mean that it will work tomorrow. So, and for this task, I also implemented in my device. It also takes much time and many additional types of sensors because I believe it just only big data in real time, very clear data that allow very clearly make future extraction. And I added in my Iron BCI device also PPG sensor, environment sensor, temperature, humidity, accelerometer, gyroscope, and some sensors about quality of air. Maybe, of course, finally I didn't use the quality of air in my research, but anyway, I created a device that in one protocol provided different types of data, not just only one EEG.
Yes, that's very interesting. And in general, brings us to your overall goal. Yes, you started mentioning what you wanted to create. At the beginning, you said BCI that is accessible, that people can use. But it seems that there were much more. You wanted to create something for everyday use, not just for laboratory experiments. So, can you give us an overview of your overall idea? What is that ideal device that you wanted to create? What was that? Or ideal, not only device, the whole system that you wanted to create.
It's a little bit about my next project because R&D side, finally, I cannot say that I achieved this task, especially because dry electrode that I used it was not so comfortable. I use a dry electrode. I love argon fluoride. It's for a long time. It's when you use it, it's very hard. It's not so comfortable. In my case, because as let's say machine learning specialist, engineer, I believe that big data set will allow us really solve different types of problems in this area, especially for future extraction. And I believe that if it will be very comfortable device, for example, like headphones or something like that, you can, for example, it's not easy to provide some device for people. For example, something new. Nobody use, at all people don't use something like that with electrode. It's very complicated. People don't like it, but everybody already use headphones, smartwatch or something like that. So in my idea in the next project, initially it was an Iron BCI, but I still move in this area. It creates something device like headphones. You can listen music. It will be a soft electrode. Actually, I'm working in this area now. And it will be, it will just only like typical headphone. So, and for this reason, it can be really very easy implemented already for different. In the first, it will allow you collect really very big data set from people because it's much more easy to use during all day. And in the second, it can be already implemented for different tasks, for stress control, sleeping control, and many different tasks can be implemented for this area if this device will be very comfortable. So actually, I'm still on this way, but I started with RMBCI, but RMBCI was an open source format, and but in the next area, it's already much more not hardware, not signal processing, much more problem with chemical and mechanical moments, let's say.
Hmm. Yes, of course. And why I want us to have this big picture to see how you actually went into implementing your overall idea. Yes, starting with Iron BCI and then going to PiEEG. Can you maybe tell us what were potential applications that you were thinking people can use this system for?
We have any general application like stress control, sleeping control, mental health control, and another type, yeah, something like that. And in my project, but I didn't climb it yet, and maybe in the future, my project, I still didn't climb about my project, for which reason I would like to use these types of headphones. I think that I will climb about that maybe in the next year, just only in the beginning of the next year. It will be device for sport, I just can say.
What type of signal do we record? What structures does it correspond to?
It's a great question. In the current moment, I just created my first prototype where electrode is located around the air. Currently, it is not inside; it's around the air, and some electrodes in the head, in the standard position. And I'm collecting data set from both area because you mentioned, we know about already standard application of electrodes. It's exactly my way. We know some information about this one, what we can receive, and and I'm working in this area now. I collected data set from head and collected data set from my ear, and already after that I try find some correlation and to understand. Okay, if it works here, can I find this information from my ear?
Mhm, mhm. Can you share any preliminary results? What do you see so far? What is the correspondence or difference between those signals?
The current moment I'm just working and I just only collected data set, so it's in the process currently.
Yes, it's too early to say. Okay, okay.
Yeah, because the much time we spend for, especially for signal processing, because how I mentioned, this device should be for everyday life. But you know what it is? Why brain computer interface or any EG signals are still used in the laboratory? Because it's very big problem with moving with any different types of artifacts. It's very big problem, and now we work much more time with signal processing for receive very clear EEG signals during walking. Exactly for this type, we already added a accelerometer gyroscope with this. We receive information from these devices to remove walking artifacts from original EEG signals. It's a very big challenge. It can be solved. It's many publications already, of course, demonstrated how it can be solved. But in our case, we don't use so much electrode. So for this reason, we cannot use very popular methods like independent component analysis or something like that to remove these types of artifacts. So and currently, we created our custom algorithm that allow us with few electrodes to remove any walking, any chewing, any blinking, any different types of artifacts.
Yes, yes, that's a significant difference between the laboratory and the world use of BCIs. And if you would list like three main differences between creating a system for just laboratory settings and real world applications? What would those be?
Totally, of course, the main difference will be in accuracy, because anyway, in laboratory, you have much more opportunity to create devices that provided you much more clear EEG signals. We understand it, and yes, but from our side, how we can solve this problem? Okay, we already receive a little more noisy EEG signals, but we receive much more amount of this EEG signals, and we especially believe for machine learning tools that will allow us make any future extraction for some applied task. In the current moment, it will be not something like medical device, it will be device for solve some problem for applied task.
Mm-hmm. Yeah, so that's number one. Yes, accuracy, and you are solving it through the increased amount of data that you can use for machine learning. What would be a number two difference that you see and you can also solve?
Yeah, so I mentioned we don't have so much channel
Mm-hmm.
and potential, and it's also limited us. Yeah, but we are working in this area, so because we use a standard location for electrodes, and we would like find optimal position for electrodes from our side. Yeah.
Mm-hmm. And number three difference that you're also trying to account for.
Only positive moment because our devices it's very easy to start use. It's not so big. You don't need to visit any specific place. You can use in your home and you can use it any places. So without any preparation process, especially at all laboratory equipment they work as well with wet electrodes, and it's not a big pleasure when you connected electrode with some types of gel.
Mhm. Okay. Now let's get back to your iron BCI. You mentioned that it was a prototype, you worked on it, you figured out many things, it provided you with lots of useful information and experience, but something probably wasn't exactly the way you wanted because you moved to a new project, which was that PiEEG. So why did you want to move to the next project? What was happening?
Great question, actually, because I didn't have any plan created something like PiEEG. It exists a few reasons. In the first reason, because I wanted created very low cost devices, and actually Iron BCI in the first stage, the cost was very low. If compared with some devices in the market, it was really very low cost. But a few years ago, it happened a chip shortage in the market, and what we received two problems. In the first, it was limited. We didn't have access to many different types of integrated circuit, and in the second, the price for integrated circuit significantly increased. And unfortunately, my device that I created, RMBTI, the cost also increased few times. It's not just only 10%; it really increased few times, maybe three, maybe four times. And I understood that okay, and that I lost my main mission, and I didn't want to give up. I understood. Okay, it's great idea. Just only take one board from my RMBCI because RMBCI actually sandwich format. It is a power supply, analog digital converter, and microcontroller. And I just only take analog part of this device and implement this part for shield that can be connected to Raspberry Pi, significantly increase the cost for this device and make much more easy to produce it. And it's Raspberry Pi. It's very big. It's I believe that it's the most popular single board computer in the world. So, and for this reason, I chose this Raspberry Pi device in already established market. And usually people use this setup exactly for learn something new. And I understood that okay, with Raspberry Pi, it will receive opportunity very easy learn neuroscience area.
Mhm. Yes. For those who are not familiar with Raspberry Pi, can you give just a brief overview? What is it?
It's very easy. It's just computer, but a very small computer that can and the main and With this computer, you have access for something outputs, discrete outputs, and it's very easy connect any digital protocol like SPI, what was used in my case, and another type of protocol. And you can very easy control some external object. Let's say it's very small computer where you have access, connect everything what you want.
So for your system, the person would need to get a Raspberry Pi, or maybe they already have it, yes, but to have that part, and then they would add your part and connect to Raspberry Pi so that they can use it for a real BC application.
Unfortunately, in the first stage, also maybe it was not so easy, but anyway, it was necessary connect out and keyboard, mouse, it was necessary connect monitor, power supply, and also necessary buy and head and electrodes. Particularly, okay, maybe we'll talk about that a little later because particularly I have solved this problem in my next project, the next generation of PiEEG.
Okay, so now let's talk about PiEEG, the generation that came after Iron BCI. Yes, so the biggest change that you made, you connected it to Raspberry Pi. It become possible to work with them together. What were other changes that you implemented? How this new system differed from the initial one?
Different things. When you use standard some brain computer interface, you need to transmit your data to laptop or something like some external devices. And in these devices already should be installed or should be in some way implemented some libraries. It means that users should install this library, take some time. But in PyEG, it is great that you don't need to transmit data because you receive data from both and directly work with this data already in Raspberry Pi. And in Raspberry Pi, already much more easy to implement libraries for work with this data, for make signal processing, for make visualization of this data. So it's much more easy than just use some typical brain computer interface. And especially for people who not just only measure EEG, but who would like implement this device for some his custom task. It's much more easy make change in software, much more easy implement for his ideas.
Mhm. Yes, you also mentioned that in iron BCI you had silver chloride electrodes initially. So in this pi BCI, what electrodes did you decide to use?
Same, actually, yeah.
The same,
Yeah.
silver chloride. Okay, okay. So no change with that. Anything else, hardware or software wise, that was different from the previous version?
More easy, how I mentioned, is that it's just only analog part because all digital parts already implemented in Raspberry Pi. So it's just only analog part from this way.
Mm-hmm. Okay. What change maybe you notice from the consumer perspective or people who were working with your system initially? Yes, do you remember the ones who were provided feedback from the very beginning? Did they also start using your new system, and what were their response to the change that happened?
Yeah. Actually, the main idea was create a PyAG for people who in the first would like just only to feel, to start with make something with neuroscience. Especially now, it's neuroscience becomes very popular. It's many projects already in this area. Everybody know in the current moment about Neuralink and another types of company like that. So, and of course, now many people work with machine learning software. The reason my main idea was solve this problem for these people who just only would like test how it works. It will be comfortable or not. For this reason, I wanted to create something with very low cost. In the second, it's for study neuroscience, but yeah, particularly it will be implemented already in the next generation in the course with EEG neuroscience.
Mm-hmm. Mm-hmm.
Let's say just on the easy way for people who would like to see what is it neuroscience in real life.
Yes, and actually, we have quite a few people who are asking, "How can I get into this? How can I, make get my hands dirty?" Yes, working on some BCI project, the first one. So, with your system, what would that be? How would that experience look like? The person who wants just for the first time to do his first BCI experiment. Can you just guide us through that? So they received your PiEEG system. What happens next?
Follow your situation, because some people just only wanted to see how it works, they just only measure, and after that stop work with this system. Some people wanted to control some external object. We are blinking, for example, it's very easy. They autoplay it without processing and finish it. Many people just wanted to implement his startups, but they didn't have hardware and wanted just only test his algorithm. But actually, many people who bought these devices, that bought it for some research, actually from university, and I didn't expect, because sometimes I had communication with some staff from university, and I explained it, guys, it is not medical device. I really would like to use it in research, but they explained it is not problem, because we can measure noise before making many research, and people know exactly about most of this device, about characteristics, so we can use it.
Very interesting. So something unexpected that you witnessed.
Yeah, it was maybe it wasn't my problem, since I did it. I created PiEEG in the first stage just only with 8 channels, because I believe it for people who would like just only test what is neuroscience. There's not necessarily more channels. But after that, I received many messages that we need much more channels
Mm-hmm, mm-hmm.
than just 8. Yeah, I didn't expect that, absolutely.
Okay, okay. So you received the feedback, and what did you do? How did your next generation of PiEEG came to existence?
Generation will be totally different. It will be in the head of this device. It will be also Raspberry Pi and PiEEG, but actually it will be kit. It will be box, like laptop. You just only open inside this box already will be monitor with installed libraries, and the main that also will be installed and course to learn. It will be currently it's Python and EEG for signal processing, but after that I will add machine learning and EEG with Python. And you open this box, inside will be already had with electrodes. It will be special mark where you will connect this electrode, and everything what you necessary. And also will be electrodes for EEG, for EMG, and for and also different types of sensors, environment, PPG, body temperature, air. It should be very comfortable, because anyway, if you bought just only PiEEG, you should think about where you will buy head, where you will buy electrode, where you will buy something another part. But in this case, it will be just only box you open, and that's all. Everything already should work. And currently, this device already in produce in the factory, and I believe in January I will receive my first prototype.
Oh, that's absolutely amazing. Very exciting time. Yes, 2024, just the beginning. You will be receiving the first prototype. And you mentioned that everything will be together, even a laptop with the Raspberry Pi with pre-installed libraries and things alike. Did you establish collaboration directly with the Raspberry Pi producers? How did it work? How are you combining those two products? Your product and Raspberry Pi.
I don't have connection with Raspberry Pi, but I believe that they know about my project, because they published a story about PiEEG on the Raspberry website. But currently, in this project, participate a few factories. In one factory, they will assemble this device. One factory will produce head, electrode, cable. One factory will produce PiEEG device. And we are working much more in the Cardmon with software. And finally, software will be implemented in this box, and it should be ready.
That's absolutely amazing. So now let's give our listeners a perspective of what they will be able to learn with this system. So they receive this box that has everything they may want to start learning about BCI and trying things out. And even a course. Yes, there will be a course that they can go through and learn. So tell, please, our listeners what they will be learning about.
I hope that this device will be interesting for university, for something like robotics school, especially we consider the opportunity. Additionally, I want implemented inside this box mechanical arm for control via brain, but we didn't find any places. All mechanical arms is too big, so it will be external in the next stage that's connected. And I believe that it will be very interesting for robotics school when you control some robotic arm, robotic toys with your brain, because it can be very useful for people because in this case you will learn not just only neuroscience, you will learn also electronic, signal processing, software, mechanical, and also yes, for people who would like move forward in this area, it will be already provided course for signal processing with EEG in Python, especially. It should be very easy to understand, for see how it works. And the next it will be machine learning. And anyway, continue my idea in neuroscience, let's say neuroscience for everyone. So it should be very easy way, much more easy than just only PiEEG. It really should be just only open box and you can work exactly from this moment. Don't need connect any cables, don't need install any libraries, don't need spend your time. Because anyway, I'm engineer, but I really don't like when I receive some new equipment, I need to spend sometimes much time to understand how I need to connect this equipment, how this equipment should work. So in this area, for this reason, I would like solve this moment, solve this problem, and make a really provide a very easy way. Just only open and start measure EEG. Not only EEG, actually it will be bio border for bio science, bio laboratory, let's say.
Absolutely a wonderful idea. Now the question is, at what level of knowledge should the students be? What do they need to know already to start working with your system? Let's say their initial knowledge of Python, engineering, robotics. What is that initial background that they need to possess to start working with your system?
I believe the main moment here is necessary to have passion for this area. If you're really interested in that, you will receive results and you will achieve some of your task. It will be nothing stop you. But of course, anyway, about background, of course, you need to know about something like, of course, basic knowledge about Python. It is necessary. But I believe that in our days already, it is everybody has some knowledge about programming. Maybe I'm wrong, but I won't believe. But the main, of course, is passion because I meet with many people who connected me that they would like use this device, and sometimes just only some person read my story about this device. They connected me, and also I was very friendly. Now I'm a little more busy, but previously I always answered and try to help some people. And many times it happened situation when some person didn't have any experience about neuroscience, about Python, but he really he had passion. And finally he achieved some results. And after some few months, maybe I again connected with these guys and I see, oh my God, he really already understands. He already received some knowledge. So because he wanted.
Yes, yeah. And many of our podcast guests talk about that the passion is number one factor that can contribute to your success and in your studies and your career in general. So thank you for mentioning that as well. And can you tell maybe what are advantages of your system to maybe some other products that are on the market? So while you were developing the system, it took a couple of years. Yes, some other products maybe appeared on the market as well that provide these open source opportunities and opportunities to learn. So what is the advantage of your system that other systems don't have?
Initially, I didn't want to make something unique, something better that exists in the market. I just wanted printed, very low cost and very comfortable devices. And it's really true. I didn't have any task initially for commercializate that. It was just only open source. I'm engineer, and for me, I was wrong actually, but few years ago, for me, it was obviously that if it is open source, it means that everybody can do it. But no, I was wrong. Many people sent me messages and asked me, we would like to buy it. I explained, don't worry, guys. It is really open source project. You can do it yourself. They explained to me that we don't want to spend my time. I'm not engineering. I absolutely don't want. I don't know what is it. What is it? Is it source? What is it? File that you provided? After that, I understand, okay, I will create manual. And I created PDF manual how everybody can make order with my source in the factory. But anyway, people continue, send me message that they would like buy. After that, I created manual in YouTube with video explanation, step by step, how everybody just can make order in the factory. But anyway, people continue to send me message that they would like just only buy. And after that, already I understood, okay, I will launch this device in a crowd supply platform. And already from this moment, I started thinking about maybe it's a good idea for commercializate it because it's really understood it's great, not only from commercialization point of view, it's in the point of view of networking, of my knowledge. When I started my project in crowd supply, my networking increased much more time and I received many interesting experience because I received many ideas, many visions, what I can improve for some people. So for this reason, and I start my step-by-step move in this area. And I cannot directly in the current moment say that my device is better than some device available in the market. It will be from my side. I believe that it will be not clearly. I just would like to say that my task is something low cost and comfortable, and that can be used in real life, and for everyone.
Yes, very good. And very interesting that you started talking about commercialization, which, like you said, wasn't the goal in the first place. And you needed to develop certain skills in this commercialization domain. How did all work for you? You needed to establish some connection with the factories, yes, where they will be now producing your devices. You needed to think about the cost of different materials and whatnot. So, also about possible marketing of your new products. How did you learn all of that? What was this curve of learning that happened to you?
So, fortunately for me, the most part of this area already I had experience in this area because I worked at hardware. I worked many years in different types of factory. I know where I can find some parts. I know how I can order this part, pre-order this part. So this area it was like my second home. So it was very close for me. It was absolutely not any problem. But about marketing, I cannot say that I pay attention for that. Since my device was open source, it was very popular in media and for people. And that usually some reporters, some media just only connected with me and asked about this device, about opportunity to write some story about that. From my side, I can say that I just only sent message to Raspberry Pi and mentioned, guys, I created a PiEEG. It will be great if you mention in your blog about that. And they mentioned finally, yeah.
That's very nice. And what I you can see from what you told us today that there were different components through your life, different experiences that finally got implemented in this one final product that is coming out. And your skills in hardware engineering, in software engineering, your connections to different factories, different places where you can order certain things. Can you maybe reflect on that and identify just several transferable skills that engineers usually already have that they can implement in working and developing PCI related products? What would that be?
Hardware engineering, it's not limited you in just only one area. Anyway, if you work in this one types of sensor, or laboratories, different types of science. It not doesn't mean that you cannot use your knowledge in neuroscience area. Of course, you should be very careful. You should read about that, or do it like me, just only spend 1 year and make many mistakes. But hardware knowledge can be easily implemented in many different types of area. Also, like in programming, because if you work in signal processing in acoustic area, anyway, you know about algorithms, you know about problem in real time, how work with data in real time. It can be implemented in with bio data. Of course, in any area exists obviously specific some points that you should take in mind. But yes, of course, programming, I believe that is the most important. For example, in our current projects, we have a few engineers, but everybody already have knowledge in programming, and I cannot already imagine how we can work with some person who don't have any knowledge about programming, about skills and some language. Because anyway, you work, but sometimes you receive some data, you receive software, hardware. Anyway, it can be sometimes implemented via some script, via some software that can be created. You cannot every time try your time to find some software that's available in the market. Sometimes it's necessary created by your hand, yourself. And anyways, programming is the most important knowledge.
Thank you. We have some students who are still in their bachelor's years, so they're doing their bachelor's in engineering, electrical engineering, and some of them are interested in getting into the field of neurotechnologies, yes, brain computer interfaces. And some have a particular interest in hardware engineering. What would be your recommendations for those students to get experience? They still can apply for internships at different places. So, what would be your recommendation to what areas they should get those internships in to develop into specialists in hardware engineering for neurotech specifically?
So, it's currently we have many specialists already in signal processing and machine learning. It's very popular topic. Also, it is not so big problem currently find some specialists for programming in microcontroller, but it still exists very big gap in area of FPGA or ASIC because, how I mentioned previously, now we are living in time when we work with big data, but big data cannot be implemented in the typical microcontroller. It's not easy to implement deep learning in microcontroller. It's very complicated implement in mobile phone via some application. So it's just only one way from my side. It is okay. It's two way. First way, it's created FPGA. It's necessary, really very deep knowledge about structure of computers, but it is allow implement really deep learning in the setup. So it means that future extraction can be implemented with very small devices with FPGA. And in the current moment, it is really very big gap in this area. It's very easy to check it. If you open some vacancy, you will see that it's many specialists necessary in this area. Also, actually, in my project, we have a still limited problem with this because we still use a microcontroller and thinking about switch to FPGA. And of course, in the second batch, it's more fundamental knowledge. It's about already how to integrate your system in crystal or something like that. But it's absolutely another area already. But so it's not area for just only one specialist. It's usually it's for laboratory, for big corporation. But if you talk about students, about his ambition, it's the best way to find yourself in this area, work with FPGA because it's really you can very if you have passion, you have time, you have knowledge, you really can become very good specialist, and specialist it will be required it will be really necessary in the market that you find without any problem position for you and much more you can implement it your ideas for your startup much more easy.
Thank you so much. Have you hired any people already to work on your product with your company, or you are still working on your own?
A small team, but it is not hiring. It is it's let's say it's team with people who have exactly the same vision like and me. So it's about 3-4 person. And yes, we work in this area for commercializate our headphones. And PiEEG, I also have one partner. I have found him via LinkedIn because I published my advertisement that I would like find some co-founder for my project because I already don't have enough time to implement my ideas. And finally, yes, one person. No, actually, it's many persons want to participate, but one person was absolutely amazing, and now we are working together to implement our next generation of PiEEG.
Mhm. Yes, I am asking because listeners, some of them are asking how to stand out when we're applying for jobs. Maybe even if you are not hiring yourself, you still have experience getting different jobs. Yes, you worked at different jobs. So maybe you have an advice of how to stand up for an employer within many people who are also applying for the same position in this domain. What would be maybe your recommendations?
Only one recommendation. I cannot say that it's the best way, just only from my side. It's much more easy to see and judge about the person if you can see his achievement in real life in some project. But it's much more easy to demonstrate that if you participated in some open source project. So for this reason, I just only recommend participate in some open source project because it's very easy after that demonstrate for any people what you did, what was done, because it's open. You can see what exactly this person did, how he writes this code, something like that. It's very strong actually. It's open source. It's very great option.
Mhm. Can you recommend any open source projects that are currently available in this field of neurotechnologies, brain computer interfaces that people can participate in?
Not necessarily be modest. You can create your private project if you implemented some algorithm that can work with data, signal processing, for example, like the artifacts removing or things like that. You can just only make open source with your project and just only recommendation, maybe write some story about that and Medium or something like that platform to much more clearly describe how it works or demonstrate in video how it works. It not can be just only sources. It's also necessary already demonstrate very clearly how it works and how it can be implemented for users. So yeah, but it's for it depends of area because anyway, in any area you can find some open source project where you can participate. For example, in very popular in EEG, it's libraries like MLE, where you can implement some your algorithms in this area. But in my opinion, it's much more better just create your open source project if you have some achievement and move with this open source forward. Because anyway, it improves your knowledge, it improves your networking, it maybe you'll find some new opportunities because sometimes in my time outside of projects from this area, because I'm working, for example, also with machine vision, with stereo vision systems. Sometimes I receive message from university. We have seen your project in stereo vision. We would like implemented our project. So it can work something like that.
Mm-hmm. Yeah, so what you are saying that in many cases when people create their own project, it's not that they need to apply for a job. Actually, people can contact them and offer them certain projects, certain jobs to work on. So it becomes a reversed process in a way.
Yes, I maybe it was problem only from my side because many years ago I didn't want participate in open source project because I believe that my ideas it is something great. I don't want share. But after that, I decided maybe I'm wrong and created my first project in open source format. And after that, I received many messages and established great connection. And I significantly finally improved this project because I received suggestions from many users how it can be improved. And some ideas were really very amazing. And when I received some message, I thought, oh my God, why I didn't think about that? It's open source. It is not voluntary. Actually, I believe that it significantly can improve your knowledge, your networking, and your position in the future.
Absolutely, absolutely. If we just look a little bit back, when you were doing your day-to-day job, yes, as an engineer, When did this time come that you decided to create your own project? Or you always were trying to create something on your own? I'm just curious, when is this time when from day to day duties you decide to create something on your own? What motivates you to create something on your own project?
Uh, Motivation is very easy because I always wanted to create something much more great than just only some sensor that can measure something in the factory. So that can be applied for that can touch everyone in this world, that can help people. Motivation for me, of course. And yeah, I cannot say that it was something like a job or for me. It's a hobby. It's passion. I work with neuroscience, work with algorithm. For example, I can start working deep night when I'm totally tired. But anyway, when I work with this data, when I work with my devices, I'm happy. It's much more for me. It's much more great than just only read book or just only watch movie. For me, it's relaxed working in my home laboratory with my algorithm, with my setups, with my devices. And usually I have a good network in this area. Every time I have connection, I achieve something. I have ideas I can share with some guys. Or what to think about that? Look at what my algorithm can do now, but I don't know how it can be better. Maybe you know something. So it's very life process actually. Yeah.
Yes, absolutely. Not only you found your project, your passion, your fulfillment, but also a network of people that you connect with, and you feel like your own tribe that you can communicate with and get feedback and
Yeah,
so on and
absolutely.
so
It's
forth.
very important, yes,
Yes.
because yeah, passion is good, but sometimes if you will work alone during long time, uh, sometimes you can burn out. You can sometimes mm, lose your mode. Yeah, it's not so easy actually. Work alone during long time in one project. For this reason, it's great if you have some networking, if you have some opportunity, share your result, communicate with some person about your achievement. So for this reason, open source is great. It provides this opportunity for everyone.
Yeah. And
Today, I'm like ambassador of open source project.
very good, very good. Thank you so much for advocating for that. And we can see from your example how really it can open opportunities and create amazing things. My question is that in the life of each person, there are times when we feel tired, we don't want to do something, especially like you say, a long term project. Did you have any times like that when you just didn't want to continue, maybe wanted to pause, wanted to stop? If so, what motivated you to actually continue with this work?
It depends of situation. But from my side, when I moved to UK, I met with one great person. Already, really, I'm a little tired from my project. I wanted to try something new, and I already didn't believe that I can achieve something really good level in my headphone. But when he heard about that, he said that, "Oh my God, it's really amazing," and yeah, he inspired me very well. And after that, we start move together, and some another guys participated in our project. So I believe that it's necessary just only meet the right person if you lost your if you lost your ambitions or something like that.
Yeah, yeah. So sometimes we have something, but we're afraid to speak about it. But actually, in your case, it helped speaking out, discussing your plans, your ideas, your challenges at that point, and you the support. Today, you mentioned, of course, machine learning, computer vision, various algorithms for real time data analysis, for denoising the data, and so on and so forth. So, which requires a lot of technological improvement and knowledge in that. My question is related to what's going on right now. We have a lot of changes in technology, in software development, let's say machine learning, AIs, yes, language models are being developed right now. So a lot of new innovative approaches. What approaches are helping you in your work? What maybe inspires you? What current technological development inspire you in your work?
Any technology when there is some new inspires me, and any technology that can improve health. some life for some people. Every time when I read this news, I understand, okay, it's really great, it's just amazing. And I feel that I am moving in the right direction because I am also would like to do something great for people. And it depends of anyway, sometimes you just open your news and see, for example, what achievement from Mark Zuckerberg and virtual reality. It's very amazing. And I have seen that. I understood that and brain computer interface also can be implemented in this area. We can express virtual reality, our internal world, our mood, when you're happy, when you even you're not, it will be very great opportunity.
Mm-hmm, mm-hmm. Do you see any integration between the virtual reality and the system that you are creating in the future?
We are not working on that, but we of course we take in mind this area, and I believe that it will be necessary, and I believe that finally it will be implemented, especially in virtual reality, because it's very great. Because when you're talking via chat, virtual reality is something like anonymous, and so maybe its problem is not so close, and we don't feel your opponent. But if we will transmit our world, let's say, internal your world, your mood, maybe it will be much more close, maybe it will be much more friendly, and maybe will allow people communicate via virtual reality, but they will feel that they communicate like in real life. It will be much more real.
Yeah, and speaking about that, we are getting into a question of the future of neurotechnology. So, how do you see this future in, let's say, 10, 50 years, maybe even 100 years from now?
I really believe and hope that this technology already will be used not just only for tasks like stress control or mood control. It will be much more used for people with disability, for solve problem with speech, with blindness, and another much more serious problem with health. And that will be very cheap, very easy, and very easy for using, and that will solve a real very big problem for human. For sleeping control and non-control control, of course, it's also a very big problem, to be honest. But I would like to talk that it will be used from the point of engineering for much more complicated tasks and for much more for people who have so serious disability.
Hmm. Thank you. And what are your plans for the future?
About the next year, I believe, because we are working very strong with our headphones and how it will depend about our success in this area. Because I have very big plans in this area, very big ideas where it can be implemented. What about that? It's for speech, for people who have speech control, blindness. I believe that it also brain computer interface can solve this problem in the future. Yeah, it will depend how what happens in the next year. Let's see.
Okay, okay. What would be your recommendation for those people who want to explore possibilities to create a startup, to create their own product, their own device?
Very clearly know for which exactly task you would like to use your device, why you would like to use it, or why another devices cannot solve this problem. It's a very clearly need field market about this problem. Yeah, anyway, it's not for any startups, it's not a big chance that it will be successful. So for this reason, my recommendation is just take areas that will inspire you without the final result. Because if you feel that it will be tragedy, if you will not create successful company, maybe it will be not good idea. But if you anyway believe that anyway you will be happy because you will achieve some technical result, anyway you will make some contribution to healthcare, and it will be at least something uh, that you will be like. So quickly you can move in this area. So I believe that don't need thinking just only about money, but it's only just my vision for me. So how it works in my way, because I work in this area already many work, and I still continue just only I really believe that, and it's really that I like and inspire me.
Yeah, absolutely. Thank you very much for sharing this. And as we are nearing the end of our podcast, can you share information about how our listeners can learn about you, your products, and how they can connect with you?
Yeah, it's the best way. I believe that via LinkedIn, it's PiEEG, our page, also I have website, PiEEG, or just only send me directly message. because in the next year I believe that I will have many updates in my project, because two projects still were not I didn't plan it about that. So in the next year it will be many new ideas, new projects.
Wonderful. We will add all this information into our podcast notes as well, so our listeners have all those contacts and information. What would you like to share with our listeners as we end our podcast? Any final recommendations? Anything you would like to say?
Believe that I already said too much about that. Yeah, and that just only do what you like, and it's more than enough. So and be happy. It's the most important.
Yes, thank you. That's great, great suggestions. Thank you very much, Ildar, for this inspiring conversation. I wish you all possible success with your project, and I am personally already am very curious and want to try your new product out. So I will be looking forward to any updates on how this project is developing, and new product is coming in January. Thank you.
Thanks so much for this conversation. It really was a pleasure for me.
Dear Neurocareers podcast listeners, thank you for joining us on this incredible journey into the entrepreneurial world of neuroscience and neurotechnologies. I hope you've been inspired by the stories of those who are turning groundbreaking ideas into impactful realities. If you are looking for more guidance on succeeding in neurocareers, book a free consultation with me, your podcast host, Dr. K, at the Institute of Neuroapproaches. So, what are you waiting for? Let's navigate the path to success in the world of neurocareers and make the impossible possible together.